Lesson 33, Hypothesis Testing Procedure for One Population Mean. Example 1. Based on past experience, Professor Sullivan hypothesizes that the mean number of hours Sierra College elementary statistics students study in a typical week is less than 16 hours per week. Test Professor Sullivan's hypothesis at the 5% level of significance using the Sierra College Elementary Statistics Student Survey. So in this example, we'll be testing Professor Sullivan's hypothesis at the 5% level of significance. Thus, we'll be conducting a hypothesis test procedure using the level of significance alpha of 0.05. Now, Professor Sullivan hypothesizes that the mean number of hours Sierra College elementary statistics students study in a typical week is less than 16 hours per week. So this verbal form includes the mean, which is denoted statistically as mu. And Sierra College elementary statistics students is just one population. So we just have our one population mean mu is hypothesized to be less than 16 hours in a typical week. This can be expressed statistically in the form of mu less than 16. So we'll be conducting a hypothesis test procedure for one population mean. So the following steps will be used to perform our hypothesis test procedure, starting with stating the hypotheses statistically. So we did that. Professor Sullivan's hypothesis was that mu was less than 16. That is, the mean number of hours Sierra College elementary statistics students study in a typical week is less than 16 hours per week. And if this hypothesis is valid, it's true that mu is less than 16. But if the hypothesis is not valid, then mu is not less than 16. And if mu is not less than 16, mu is the opposite, greater than or equal to 16. Now, greater than or equal includes the condition of equality. So we always label HO the condition of the equality. And the opposite, without the condition of equality, is always labeled with H1. So in this hypothesis, we're conducting has HO of mu greater than or equal to 16 versus H1, where mu is less than 16. In this case, Professor Sullivan's hypothesis is included in H1, where mu is less than 16. So Professor Sullivan's hypothesis is valid if H1 is valid. Professor Sullivan's hypothesis is not valid if the opposite idea, HO, is valid. Now that we've set up the statistical form of the hypotheses, we then select alpha, the level of significance. Here, we're using the customary alpha of 0.05. Next, t-test is the command on the TI-84 calculator that will help us calculate the p-value we need to reach our decision. But in order to calculate the p-value using the t-test command, we need our sample data. So it was question 8 on the Sierra College Elementary Statistics Student Survey that asked the students, on average, how many hours do you study in a typical week? I've already taken the time to enter this data into my calculator into a list that was named Q8. So to do the t-test command, we press stat, arrow over to tests, and then arrow down to t-test, where we press enter. Now here we have the actual data. So we arrow the cursor over to data and press enter to select data. Down arrow. Mu0 is the actual value that shows up in the hypothesis. In this case, it's the 16 hours per week. So I enter in 16. Enter. List denotes the list where the data has been entered in the calculator. To get to the list, I press second and stat to display the list of data. I use my arrow to move the cursor next to Q8 for question 8, hours studied, press enter to select. Frequency is 1 because each of these hours studied came from one student. Down arrow, H1 has the condition of less than, so I arrow over to the less than, press enter to select, and then down arrow to calculate. The calculator will now calculate the resulting p-value, in addition to several other results. But the only result we're interested in to make our decision is the p-value. And the p-value is denoted as the p equals. Here, rounding off the p-value to the nearest thousandth, the p-value is 0.010. Now that we have our p-value, we can reach our decision. Since the p-value of 0.010 is 0.05 or less, the decision is to reject HO. When we reject HO, that indicates we have sufficient sample evidence to indicate that HO is not valid. And if HO is not valid, the opposite idea, H1, is valid. Thus here, the data supports the idea that mu is less than 16, which was Professor Sullivan's hypothesis. Thus, Professor Sullivan's hypothesis is valid. So, given the work we've done in our hypothesis test procedure, we can now state our conclusion. Therefore, Professor Sullivan's hypothesis that the mean number of hours Sierra College elementary statistics students study in a typical week is less than 16 hours per week is valid at the 5% level of significance.